Okay, now the first order linear differential equations, we will learn on the first one, which is on the separable equation. Okay, when we have dy dx in terms of function of x multiplied by function of y, so we can separate them in order to solve the differential equation. So solve the differential equation means we want to find the y, okay, we want to integrate it. So first step is we will have to separate, okay, y will be on the left hand side, okay, left hand side, x will be on the right hand side. After that, the second step is we will integrate both sides separately, okay, left respect to y and right hand side respect to x, and then we will obtain the general solution. Okay, after that, if you are given the initial condition, you need to substitute the initial condition, so you will get the particular solution. So let us take a look at the example. So the first one, solve the following differential equation. Okay, this one dy dx. Okay, you see we can separate x and y. Okay, so this is separable equation. So how to solve separable equation? By separate them first. So it will be 3y power 3. Okay, we bring y to this side and the dx to the right hand side. Dy equals, the rest maintain. Okay, the next step is we'll integrate it. So 3y cubed, 3y power 3 will integrate with respect to y, 3y power 4 divided by 4 equals to 4x squared over 2 plus c. And then okay, we bring 3 over 4, so y power 4 is equals to 4 over 3. This one is 2, 2x squared plus c. So next we simplify it, you will get 8x squared over 3 plus c, 4 over 3 c. Okay, we can stop here or we can simplify it more. It will be y equals to root of 4 8 over 3x squared plus d. Okay, where d is equals to 4 over 3c. So it's just a constant. It doesn't matter what we call it, unknown you want to, so there is c, d, e, okay, other than the variable x and y. Okay, that's it. So I repeat, we will have to separate y on the left hand side, x on the right hand side, and then we integrate both sides respectively, and then after we integrate, we simplify it like this. Okay, if you can write in terms of y only equals to what, then you write it. If not, you can just stop here, it doesn't matter. Okay, so let us take a look at the second example. Okay, find the particular solution of the following DE when y equals to 2 and x equals to 0. So first, you see, okay, is this equation can be separate? Yes. Okay, yes. So we separate it first. So y here, we move here. So dy over y squared equals to, okay, and then this one we move to x. So x exponent x dx. Okay, next step is you want to integrate them. So y 1 over y squared, before we integrate, we move to the we change into power form, so it's easier for us to integrate it. So now y power negative 2 will be y negative 2 plus 1 will be negative 1, divide by the new power, which is negative 1. And then this one we need to use by part or tabular method. So in this case I'll use tabular method. So the first one is signed, and then we have differentiate, the one that we want to differentiate, and then integrate, the one that we want to integrate. So sign here is positive, so differentiate will take x, because when we differentiate x, eventually we will get 0, and the exponent x dx, you will have to integrate it. So the sign is alternately change, and then differentiate 1 you get differentiate x you get 1, differentiate 1 you get 0. So you stop here. Only 3 times. Exponent x, you still get exponent x, exponent x. Okay, you have to write it like this. Okay, this one is not compulsory. Okay, so now this is how you take the answer. Okay, by following the arrow. So the answer will be x exponent x. Okay, this one multiply, multiply. Okay, so minus exponent x. So that's it. X exponent x minus x plus c. So that's the answer when you integrate them. So now we want to write in form of y. So this one on the left hand side is actually negative 1 over y. So if you want to write in terms of y, maybe we can bring y to the other side. So it will be negative 1 over x minus x plus c equals to y. Okay, you can also write like this. So now it's given the initial condition. So we don't want the c. We want it in terms of the particular solution. Okay, so substitute x equals to 0, y equals to 2 from the given condition. So you will get y. Okay, y is 2. Okay, I change the place now. Divide by 1 over 0 x times exponent 0 minus 0 plus c. So this one 0, 0. So c must be equal to negative 1 over 2. Wait, this one is exponent 0, right? Exponent 0 here. Sorry. I copied wrongly. Yeah, okay, this one should be exponent x. This one is exponent x. So here is exponent x. So exponent 0. So here is 1 is 0. So c is equals to 2 is equals to negative 1 over negative 1 plus c. Right? So c must be equals to 1 over 2. Okay, so we rewrite again. The final answer would be y is equals to negative 1 over x exponent x minus exponent x plus 1 over 2. So this is the final answer that we want, a particular solution. So remember, when we are given initial condition, we need to find what is the value of the unknown C. Okay, so that's it. So the next example, okay, again we separate them. So dy divided by y squared minus 1 is equals to 1 plus exponent negative x dx. And then we integrate both sides. So how to integrate y squared minus 1? What do we get? Okay, come on. What's the answer? Integrate the x first. We'll get x plus negative exponent negative x plus c. What about the y? So for this y, you need to apply, we call it partial fraction. Okay, partial fraction. So 1 over y squared minus 1. Okay, the partial fraction will be 1 over y minus 1 plus 1 over y plus 1. Sorry, not 1. AB. Okay. So the answer, we want to find what is A and B. So 1 is equals to A y plus 1 plus B y minus 1. Okay, so let y equals to 1. When y equals to 1, b is 0, so we get 1 equals to 2a. So a must be equals to 1 over 2. Okay, when we let y equals to negative 1, a will be 0, so b is equal negative 2b is equals to 1, so b must equals to negative 1 over 2. Okay, so this is the partial fraction. So now the answer, okay, we will have to integrate a, this one, a is this 1 over 2 over y minus 1 minus integration of, okay, dy 1 over 2 y plus 1 dy. Okay, we put the minus here. Okay, so now we'll have to integrate it. How to integrate? 1 over 2 is the constant. 1 over y minus 1 will be ln y minus 1 minus 1 over 2 ln y plus 1. Okay, so for the right hand side, for x, we just follow it. Negative is negative x plus c. So that's it. Normally we will have to simplify it. So 1 over 2 here, 1 over 2, 1 over 2, we take out the 1 over 2. So the ln we can combine. So if it is minus, so it will be over side here. Okay, this equals to x minus exponent negative x plus c. So now we bring the 1 over 2 here to the right, will be 2x minus 2 exponent negative x plus 2c. So now we want to eliminate the ln. So how to eliminate the ln? We put it exponent. We put exponent. So when we put exponent, it will be y minus 1 over y plus 1 is equals to exponent 2x minus 2 exponent negative x plus 2c. Okay, and then we continue here. Y minus 1 over y plus 1 is equals to exponent 2x minus 2 exponent negative x times exponent 2c. So y minus 1 over y plus 1 is equals to a exponent 2x minus 2 exponent negative x. Okay, where a is equals to exponent 2c. So this is the final answer. We can just stop here. Okay, that's it. So maybe important I think. Formula that you need to know on ln, the basics one. Okay, if ln x plus ln y, you can write as ln x times y, the inside function. So if it is ln x minus ln y, it will be divide. And last one, if we do exponent ln x, you will get it equals to x. And another one, ln 1 is equals to 0. So these are some important concepts, okay, in ln that we will normally apply in this method. Okay, that's it. So the answer that we want is this one. Okay, the last example. Okay, still separable equation, but now it is a particular solution. So you find the general solution first, where we need to separate them. So y dy is equals to tangent to x dx. So you will have to integrate them. Okay, integrate y, we will get y squared over 2. How to integrate tangent x? Tangent to x. So normally this one we will use substitution. So first we will change the tangent in terms of sine over cos. Okay, sine to x over cos to x. So we will have to use substitution for this. So we will let u equals to cos to x. So du over dx is equals to negative 2 sine 2x. So dx is equals to du over negative 2 sine 2x. Okay, so it will be sine 2x divided by u. Dx is du over negative 2 sine 2x. So it's cancelled here. So we'll just have to integrate. So this one is the same. Negative 1 over 2. Negative 1 over 2. 1 over u du. Okay, integrate 1 over u is du. This one is still the same. Negative 1 over 2 ln u. Let's see. So we don't want the u. We want the, now you're right. Okay, we want the x. So u is equals to this one. So we substitute back. Ln cos 2x plus c. So you can just stop here, it doesn't matter. So now we want in terms the particular solution is given here. Okay, when x equals to 0, y equals to 2. So we substitute 2 squared over 2 is equals to negative 1 over 2 ln cos 0 plus c. So cos 0 is 1. So ln 1 is 0. Ln 1 is 0. Sorry, what am I writing? Ln 1 is 0. So it's 0 here. So this one is 4, 2. So c is equals to 2. Right? Because this one is 0 multiplied by 0. So you get c equals to 2. So the answer will be y squared over 2 minus 1 over 2 ln cos 2x plus 2. Or you can equation equals sorry about my writing. Okay, so okay, now if you want to write the, you bring the 2 to the right also can. So you'll get negative ln cos 2x plus 4. That's it. If you want to write y only, you can put the square root. But it's enough if you can stop here. Okay, that's it. So this is for separable equation. I hope you got the idea. We need to separate the equation, and then we integrate both sides respectively, okay, separately, and then we will simplify it. We get the general solution. If we don't have, if we have initial condition, we need to substitute in the general solution so that we get the particular solution, meaning normal C. Okay, so what if the equation, the differential equation cannot be separate? Y on the left and x on the right. What happened? So that one, we need to consider another method to solve it, which we will learn on the next video. So for the time being, so please try to do this exercise and submit it as exercise 1. Okay, that's it. Thank you.